Let's go ahead and get started. Hi, everybody. How are you all doing today? Were you able to get your design document in on time and successfully? You're not late. It's fine. So, good. I'm glad that everybody seemed to get it done. Were there any questions that came up while you were working on it? Yes? 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 You don't have to do that in your design, but you should do that in your program, right? There's not as many constants as last time, but there are still constants. Yes, sir. I'll work right left. Yes, ma'am. Yep. Yep. I named mine things like K systolic factor, K CRP factor, stuff like that, a name that kind of indicated what they were doing in the equation. So. Okay. Other questions? Yes? Uh-huh. I want you to say which field is wrong. Yes. Yes. Okay. In mine, I went to the next line. So it's fine. I mean, as an exercise, it's fine to go to the next line. In reality, what would happen is if you wrote this program and it started throwing data errors, a human would have to look at it and figure out if the data was right or not, right? The nice thing about continuing to run after you find one data error is if there are other data errors, those will get thrown up too, so someone will be able to see that there are multiple errors. Does that make sense? Yeah, so if there's like 10 lines and 4 of them have bad things, it might say subject 3, blood pressure out of range, subject 4, CRP is way too low, stuff like that. And then if you do that all at once, the person can look and go, oh, look, here's a whole bunch of errors, I can check them all now. If you run it and it just goes subject 3, blood pressure out of range, and it stops, they go and check that, and they run it again, and that throws another one, and it's annoying, right? It's easy for us to just check them all at once and throw all the error messages at once. So we can do that. Does that make sense? What my program does is it actually does the average of all the lines that are found that are good, right? So, yes, sir. Uh-huh. Great. Other questions? Now, the reason I'm not answering these questions is not just because I'm in a bad mood today. It's because at the end of class, we sped up and went through stuff pretty quickly. And the questions I'm being asked are things I'm going to talk about today anyway. Does that make sense? So I'm not blowing you 3 off. Other questions? Sir? Yep. Yes?
I remember you talking about this briefly before, that if you've entered the library, but it doesn't run with that library, what should you do then?
If you've entered the library, but it doesn't. Like pound include, whatever?
Like pound includes math.h.
Uh-huh.
But the computer doesn't want to.
Oh, you get an error?
Yeah.
For math.h, you also have to include a dash. On the compile, when you type G++, you also have to say -lm anywhere on that line, and that should fix that error. Dash lowercase l, lowercase m, all 3 together, -lm. And that will fix the compiler error for the math library. And some compilers require that and some don't. So sadly, it would be every time you use the math library you need to do that. Yep. Sir? We can't. We're going to read them one at a time out of the file. Nope. We are. When we read the line, we're not using getLine, right? We're using CN, and we have 7 data values, and we just check each one of the 7. Uh-huh. Yep. Yeah, but you do it separately. When you read the line that has subject 3, you check that and you say subject 3 is bad. Then you go up to the top of the while loop, read the next line, and do the same thing. for purposes of calculation. Sir?
If there's more than one value out of range on
Uh-huh.
the same line, do you want us to point
Uh-huh.
out all of the mistakes or just
Yeah. Yep. I mean, you're checking them all, right? We want to be good to people. I mean, people range from imperfect to suck, but that's no reason to crap on them if they do something wrong, as much as I like to write that into my own code. If we're really writing something and we're doing data checking, let's just do it all. Let's tell them everything that's wrong before we stop, and then they can fix it, right? Have you ever run a program where you do something and then it comes back and it goes, oh, you still suck, right? You're just like, stop, just tell me at once and I'll fix it all. Don't make me do it over and over. So that's sort of my philosophy. Other questions? All right, so one thing I need to point out is that my solution to this project was horrible, right? I was actually in a hurry when I wrote it, and it turns out that I missed a bunch of stuff in my code. So it's been updated like 3 times because people keep finding bugs. Who's found bugs in my program that I've emailed about? Here you go. You didn't find a bug? I don't care. Just do it now. Come on, there's more. There's been like 4 or 5 bugs. No? No one? Anyway, it's getting better. Sorry. I messed up some stuff. So, yes?
When you give us sample code,
Uh-huh.
you're just giving us the program, right? You're not
Yeah.
giving us the background, right?
When I give you...
Like the CC file.
the CC file should not be in my account. And if it is, you should not be able to read it. I'm very careful about that. The thing I'm giving you is the executable that's been compiled. And if you are able to take the compiled executable and get source code out of it, I will just give you an A for this class. Okay? And you don't have to do anything else. Just once you've decompiled my program and send it to me with like the right stuff before I post the solution, you win. Okay? Challenge for you right there. All right, maybe I can't really do that, but it's really hard to reverse engineer. It's really hard to reverse engineer the binary and come up with good stuff. So, all right, other questions? No? All right, well, let's go ahead and get started. So last time, we talked about a number of different things. The first thing we talked about is our good friend, CN. When you see CN, what do you think? Input on the keyboard, right? And CN does some very weird stuff in some circumstances. And let's just take a second to review that. What does CN do if you give it input into multiple variables and there are no spaces between the input? Mm-hmm. Yes, it does its very best to figure out the input and match it to what it's expecting. So if it's looking for some digits, if it's looking for an int, it will find the longest int it can, and then it will go on from there, which is nice in some cases, but not nice in others. What happens if the type is completely wrong? So for example, CN is expecting to read an integer, and it gets a string or a character. Yeah. CN quits. Once something goes wrong, CN quits. It quits on you. Right? The question we follow up from that is, when does CN start working again? Yes?
Next time you do it after the program's ended.
Yes. The answer is never inside that run of the program. Once for a particular program CN is broken, it will never start running again unless you explicitly fix it. Now, I'm not going to teach you how to explicitly fix it in this class because it's a giant pain. And it doesn't really help you understand principles, but if you ever really want to know, I can teach you how to fix CN, okay? Other than that, for that run of the program, it is broken. So any get line that uses CN, any other reference to CN in the program does nothing, okay? Does that make sense? It's bad. We talked about doing file, input, and output. Remember this? Because we decided that we don't always want to have to type on the keyboard. We talked about, for input, how we have an ifstream variable that we can use in place of the CN. Other than the fact that we're using this variable, it works exactly like CN. That means if you give it a whole bunch of stuff without spaces, it does what? Well, it tries its hardest to figure it out. If you give it the wrong type, what does it do? Then it quits. And when does it start working again? Never. Next time you run the program. Okay. How do you get to access ifstream? The fstream library is required. We talked very briefly about while loops. Why do we use loops? Yeah. So we can read lots of stuff. How much stuff? As much as there is. Given that we don't know how much stuff there is going to be, we can just use a while loop to read forever until the stuff runs out. Okay? And this is useful for files. It's useful for a lot of things. And we'll talk about some other circumstances where you use while loops today. But first, what ended up happening last class was I tried to go fast so I could get at least up to while loops for you, and we skipped some stuff that is actually useful. So let me ask you a question. If we ever want to do output, like we're reading from a file and we want to output stuff, how do you think we might output to a file? And I'll give you a hint. We had pound include fstream gave us something ifstream, which is input file stream, which means output file stream. Absolutely. So there's fstream gives us two things. It gives us an ifstream and an ofstream. So let me demonstrate that. If you recognize this is the program we were playing with last time that we wrote. We have a couple of ints, a double, a character. We have an ifstream input file. We open the input file. While we're reading lines, essentially while you're able to read from the input file into these 4 variables, just go ahead and output those 4 variables. All right? Everybody with me? Now, let's say we also want to output some stuff. We will need something called ofstream, which is output file stream. And we'll call this one output file. How's that for a name? Everybody good with that? The way we get this ready to do stuff is exactly the same. Output file dot open, and then what we want to write to. In this case, it's going to be output dot text. And then how do we output to that file? Yes? Absolutely. It's just the same as cout, except with output file. So if I copy this line and put it back and I just put output file right here, what our algorithm says now is create an input file, create an output file, open the input file using the file data.txt, open the output file using the file output.txt, while you are able to read from the input file into these 4 variables, one into letter and decimal. Go ahead and output the values to the screen using cout and also output them to the output file. So this is essentially going to create a file that is a copy of our input file. Yes? No. Anything that's written to the file will not show on the screen. You have to explicitly say, show it to the screen or show it on the file. You must explicitly do both, if you want to do both. There are times where you only want to write to a file and you don't want stuff to go to a screen. There's times you only want to do to the screen and not to a file. So you have to explicitly say what you want. Okay? Yeah?
Okay, so the dot open method,
Mm-hmm.
what does that do? That writes the file? Or
Dot open for an input file opens it so you can read from it. Dot open for the output opens it so you can write output to it. Essentially, these things represent a file either for input or output, and this tells, using the open with the thing there, tells essentially what file on the file system to use for that.
okay, and so you want to do that before
Yes.
you actually input.
Yes, you have to do open before you can read or write. You must do open first. Yep. Excuse me? No, order doesn't matter. I mean, we're outputting the same thing, so I can switch order. Do y'all want to see if this works? Yeah? In here? We'll get to that. Don't let me forget. I might forget that one, but I'm going to try not to. Yes? You do. It's good practice too. But remind me before we move on from other stuff, and I'll do that as well. Yes? Nope. Mm-mm. They live perfectly happily together in harmony, both doing their own things. Yep.
So, what are you doing in the parentheses after a while?
This one?
What is that doing?
This is how we can read individual values that we know the format of, right? Because we know that our data file, which let me just show you the data file to remind you what it looks like, because I have it open right here, right? Each line has 4 values. And I keep forgetting that this projector is off. Each line has 4 values. Int, character, double, right? Or float. Int, character, float. Int, character, because we know that 9 can be a character, and a float, right? So we're just reading values out of here, and I just created this as an example. And so what the while loop does is it says, while you're able to read something from the input file, and put it into these 4 variables, which will, just like remember when we saw cin and we typed a whole bunch of extra stuff and cin like just saved it for later, the input file is doing the exact same thing. It starts in the beginning of the file, it says, oh, here's an int, here's a letter, here's a decimal, I'll do some stuff. It comes back later and goes, oh, let's see if there's some more ints and decimals waiting. And there are.
If there's an error, is it necessary to have a different while loop for if there's an error?
I don't know. Do you want to try it and see? Remind me later to show you that then. Yes? Just create another one with a different name. So so just as a quick example, I'm going to show how we can have 2 output files at the same time. Output file 2, output file. I'm going to take this code back out because I don't really want to have 2 output files, right? Output 2.txt, that's close enough. I know, but I don't care, right? So that's how we'd have 2 output files. You can have as many output files as you want. You can have as many as you want. The operating system that you're running on will limit you to a few thousand, but most of us don't need a few thousand open files at any particular time. Okay, does that make sense? So this is just another variable. You can create as many of these as you want. For this class, we're probably only ever going to do like 1 input or output file at a time. Okay. Yes?
So if there's no data in the file,
Let's look and see. Let's try it and see. Let's start running this stuff instead of doing hype. No, I'm happy to answer your question and demonstrate to you. It's just better to demonstrate to you than to explain it to you, I think. Okay, so here let's just check and make sure what we did to do some output file stuff worked. Does that sound good? So let me go over here, g++ fileio.cc.o fileio, and we'll see if it compiles. It compiles cleanly. I want to do a quick ls. This tells us what files are in here, right? We have a data.txt, which is the file we're expecting to read from. Does anybody up there see something called output.txt? Is there an output.txt anywhere? All right, so let's go ahead and run our program, fileio. And here's what it did, right? You remember it opened a file, it read it, it printed stuff to the screen, and that part seemed to work. Now let's do an ls again and see what other files are in here. Does anybody now see a file named output.txt? Yes, it is. You curious what's in there? You can use the cat command, and the cat command will just spew stuff to the screen. And there it is. And you know my policy is for me to answer that, don't you? Ah.
Math questions turn it off.
All right, do you want to take that in the hall and just like finish the math question out there, or? It's okay. All right, but you might want to check that for the future, okay? So, all right, so our program ran and it did what it was supposed to, right? It opened up the input file, it opened up the output file, it read stuff, it printed out the output contents of the input file to the screen, and then it printed things out to the output file. We good on that? Yes? The extension at the end of this file is essentially irrelevant. Okay. The reason I'm saying is .txt because it's a convention among us that that's a text file and this is just a text file. For other files like docx or PowerPoint, they have actually very complicated file formats, and the program is aware of those file formats and able to read them. Okay. We're just kind of using the simple examples. Yes. Cat just spews stuff out to a screen. That's essentially what it does. And I can't remember what it stands for. It stands actually is short for concatenate or something like that, because you can actually put multiple files and it'll spew them all out. But yeah, it just shows you what's in the file. A better way to do that, and I'll just show you this quickly, is I use cat. The better way to do it is also you can use less. And what less will do is you see instead of just spewing it out, it'll do things page by page. So if I have a really long file, I don't remember which one of these things is long, but right, it'll let me page through. And if I push the B button, it'll go back, so you can kind of page through. So less is cat will just spew it to the screen, and less will let you move around in it. Okay. All right. So everybody good with this? See what's happening here? Right? We're reading everything in the file, a little chunk at a time, and then we're able to print out those chunks either to the screen or to an output file. All right, is that good? Now, we had some different questions. One of them was, what if the output file is bad? Who asked that one? Somebody was worried about the data in there? You were? Okay, so I'm sorry, the input file. So let's make a new input file. Data2.txt. And we might have, you know, one line that's correct, and then a line that's not correct. How do you want it to be wrong? Do you want to have a missing value?
I was just saying, like, if there's no data in the file.
Oh, no data in the file at all. That's easy. All right, so here's an empty data file, right? This is named data2.txt. You can see there's nothing in it. Let's go back over here and tell this that we're going to use data2.txt for our input file. You ready? And now we'll recompile because the file name is hardwired in there. And I will clear the screen, and then we'll run it and see what happens. Ready? Nothing happened. And why did nothing happen? Because no. Now the question is, what happened to our output file? And for here, I'll do less output.txt. And there's nothing in our output file because there was nothing to read. So it output nothing into the file. Yes?
The rubric of the program
Mm-hmm.
for the second project, it says, like, does not try to input data if there's no data. So does that count in that while loop?
I don't know. Send me an email because I'm not the one who came up with the rubric, so I'm not sure what that is.
But so in the while loop, is it trying to input data if you have the input in
Yeah.
the while loop?
Mm-hmm.
So with the wording in
Don't worry about the rubric. Send me an email and I'll clarify it for you. Okay. So if there's no data, it should do what it did, which is it went to read stuff. It says, oh, I opened the input file, I opened the output file, I went to read stuff. There was no data for me to get, and so I exit out of the while loop and I returned. Does that make sense? All right. What happens? Yeah. Okay. What happens if we get some stuff wrong, right? Let's say we had an output file that was missing a value. What's going to happen here? It'll print the first line and then what? It'll print the first line, and we'll see I didn't have to recompile. Yeah. So it only did the first line, which worries me a little bit. That's a good question. Then weird things are going to happen, I think. I'm little scared to do this, but let's find out. So what it did is it tried to get what it could, just like cin did. It said, okay, here's an int, here's a character, here's a float, and then, oh, there's not enough stuff, and so it exited. So essentially what happened is when it went to try and read this last thing, it goes, okay, I found int, I found that, I found a letter. Oh, the file ended. If the file ended, this while loop is false because it wasn't able to put something into that last decimal value, and it exited the while loop without printing anything. And when we added the valid line, it picked up values, but it didn't do it line by line. It picked up the wrong one like cin did too. Which is one of the reasons I'm guaranteeing you for your input file that you will always have the right number of columns, because this is really hard to deal with. All right, everybody happy with that so far? Yes?
Okay, so when we're running a program and we're taking the user input for the file name,
Uh-huh. All right, so what you're telling me is that this sucks, that every single time that we have to put a new file in, it's really annoying to like recompile the file. How would you like it if every time you went to Microsoft Word, you had to like edit the Microsoft Word source code and compile it to get it to open the right file? How many of you think that would be good? How many of you think that would suck? It would suck. So it would be a lot better as if we could get some user input for these file names, right? All right, so let's do that. Let's create a variable to hold this, string input file name. How's that? Is that a good variable to indicate the input file name? And here's what we can do. We can say, please enter the input file name. Now, we have a choice here. Because we're going to input something, we can either use cin or we can use getLine. Which one do you think we would use here? Why? Because why? Exactly. And in particular, can a file name have spaces in it? Yes, it can. So if somebody enters a file name that has spaces, cin will break on spaces, and then it'll get confused because it won't have the right file. Okay? So we use getLine, cin, input file name. Great. Now what we're going to do is down here, we're going to replace this input file.open with the input file name. Okay. And so we output the input file name, we read it, and then we open it. Does that sound good? It's a lot better that way, right? Than just having the one that's fixed, like a fixed value, like output.txt. It's a lot better to have a choice for input. And we've seen strings before. So, right, string input file name, getLine, the whole thing, from cin, which is the keyboard file name. Everybody on board? Everybody happy with this? Who thinks this is going to work? Who thinks this is not going to work? Oh, and there's a question, yes.
so you don't need to worry about putting quotes around input file name?
Nope, because quotes mean an actual literal value, right? Like this is a string literal. This means this literal value. But when you, just like any other variable, when you say the name of the variable, the computer, being just a very dumb machine that says, oh, I have a box somewhere named input file name that I know has some string in it, I will go over to memory, I'll figure out what that string is, I'll bring it back, and I'll put it right there.
Okay.
Does that make sense? Yeah. So quotes mean, if you put quotes around there, it would look for a file named input file name.
Okay.
But if we don't use the quotes, it goes up and looks up what's stored in there and uses that instead. All right, so to get back to that, some people thought it was going to work. This makes perfect sense, by the way, doesn't it? How many of y'all think this makes perfect sense? How many of you have no idea if it makes perfect sense or not? That's fine, too. Here's the deal. I don't think this is going to work. And this is one of the things, that bothers me. All right. So here's what we did. We did something that made perfect sense. We said, hey, open this file. The file name's contained in the string. And you look and it goes, you suck. We read from the top. We say in function at main, error, no matching function for call to standard basic framework, if string, open. So something went wrong here. Something went wrong there with the string. And I'm just going to tell you what it is. C++ is built on an underlying language called the open call here expects a C style string, not a C++ style string. So we have to convert this C++ string into a C style string. And I told you when we were talking about strings that there was something about strings that made me cry, and this is it, right? You should just be able to stick a string there, and you can't. Instead, you have to do .c_str open close parentheses. And what this will do is convert this C++ style string into a C style string, which Open is able to work with. Does that make sense? This is, again, one of those irregular weirdnesses of C++. So now that I have changed our input file name C style string to a C++ string to a C style string, let's see if that compiles. Indeed it does. Okay? So the change was changing the C++ style string input file name and using the .c_str method to turn it into a C string. Everybody with me on that? And then when I compiled it, it worked just fine. I'll compile it again, clear the screen, and when we run it, it will say input the inner file name. What file name do we want to give it? Data.txt, and then it was able to find the file and open it. Yeah? Sure. Input file name is a string variable right here, which we're using just to hold the thing that the person types in for the file name. So we declare a string, which is a bunch of characters. Here we say enter the input file name, and then we read the bunch of stuff that people type. Does that make sense? And then down here, we're using that as the file name and saying, hey, go find a file name this and open it up. Okay? All right. We all good? Yes? Sure. Do you want to do it for output too? Let's do it for output too while we're at it, okay? Because we're going to have to do it for the program, right? So you make a variable called output file name. Down here, we'll say open output file name .c_string str, and then we also need to figure out, ask people what output file they want. All right. So let me just recenter that a little bit. So here's what I just did. Even though I did it very, very quickly, what I just did is just like everything we did for input stream, I also did for output stream, right? So for the input file, everything we did for the input file, I did exactly the same thing for the output file. I created a variable called output file name. It's a string. I did a prompt saying enter the output file name, and then got the output file name. And then I changed what was being opened from a literal inside quotes to what was actually read from the input statement, right? Everybody with me? You look like you really want to ask a question. Is it possible to open output files? You can open them outside your program to look at them. Is that what you're asking? You can use Nano to look at them if you want. Yes? Okay. So humans range from what? Yeah, and so do people always type file names that work? No, they don't. So let's take a look at this. So first I'm going to compile this to make sure that I didn't do something weird and introduce an error. I fortunately did not. Now when I run it, let's just check first and make sure that it still works. So it ran. If I do less output.txt, which also addresses your question as to looking at these things, we can see that it ran correctly and everything went well. So that was fast, but what I did is I ran the program. I gave it the input file name data.txt, which was the exact same name we were using before, right? Because we knew that file worked. I gave it the output name output.txt, which was exactly the same file as we were using before. And you can see this is the data file that it opened up in red, and that worked, right? Because it printed that to the screen. And then I did less output.txt, which showed the output file on the screen. We saw that worked as well. Thumbs up, right? Everything good? All right, here's what we're going to do. Take a 1-minute break, and when we come back, we'll make this go wrong and see. And I do this in part so you can stretch, but in part because I also am like videoing the class, and the camera runs out of space after about 40 minutes, and so I have to stop it. Like the file gets too big. So I have to stop it and restart it. In terms of line of code, the number of lines of code will be much shorter. The length of the code is not necessarily indicative of its complexity, though. Right. So it's not just because it's shorter, it's easier. It can be harder. Yeah. Some of it you might be, and if it's a big problem for you, just let me know and we can work it out. So, but did you look at the grading rubric for the? Yeah. So that's kind of the hint of what stuff you should include in there. And I did send out like an email trying to explain some of the stuff briefly beforehand. So.
Like I put in like the out, I put for the output line, I put in the output line, but then I didn't have it put it actually put it into the file.
You might get a few points off. It's not the end of the world. All right. Everybody feeling better? Welcome back. All right, so the question we are about to address is what happens when we use an output, a file name that is something that is not good, okay? Something that is not good. So let's run the program again and take a look and see. So we knew that we had a data file. What was its name? Data.txt, so I typed data.txt. Sorry, that's my either imperfection or suckiness showing. I typed it wrong. What happens when I enter it? I enter the output file name. Okay. This one, let's get close to. Okay. Nothing happened. All right. It didn't print out anything. Let's just take a look. And look, you can see there's this file here, outptt.txt too. And that also doesn't have anything in it. So what happened is indistinguishable. It's indistinguishable to us as to whether the DAAT.txt was empty or it just wasn't there. Right? Does that make sense? Yeah. So from the program's point of view, you cannot tell if the file was not there, or if it was empty. It would be nice to let us know if we made a mistake. Right? Wouldn't it? So, you can actually do that, and it's pretty easy. And in fact, I have been purposely excluding this, but almost every single program you ever write that asks people for a file or reads a file should do this. And what it should do is it should check. And the way you can check is you can say, if not input file. And that means, essentially, if the input file didn't work, right? If bang input file, if not input file, that will tell you something went wrong. And in a second, I'll show you another way to write this. And in this case, we can do something cout file, and I always like to give the file name. Not found. I need some quotes around that. And in this case, we can just exit. Sorry. For some reason, my code got weirdly indented. So, all right, so that's what it looks like. Immediately after you open the file, you say if not input file, or if not whatever, see out what was wrong, return 0. Yes, sir. Oh, man. Do you want candy for that? It's a pretty cheap one. Here. Dark Milky Way, the worst one. All right. So, do you want to check and see if this works? So here's what we're going to do. We'll check and see if this works. I'll clear the screen. I'll clear the screen. I'll compile. I will run the program. And again, we'll ask for dat.txt, and we'll ask for some sort of weird output file. No, I'm not going to do that. Hang on a second. And it says, hey, file dat.txt not found. Bonus, yeah?
Wait, so earlier, I think I missed this. Did the output file, did it write an output file?
It did. It created the output file.
But there's nothing in
But there is nothing in there.
there.
Nothing in there. Yes? Ah, do you? You do, but it's going to be a little bit different. Because on occasion, the user might give you the name of a file that is not allowed to be written to. Or I'll give you an example. One example is if the disk is completely full and there's no space to write it, then when you go to open the file to write, the program it'll reject it essentially. So if your disk is completely full, you know how sometimes you have permissions to files? I don't know if you've encountered that. If like you try and read a file that you don't have permission for, like an administrator file, it'll fail. I'll give you an example of that. Is there a question over here? Yes. Yes, it still creates the new output file. Is that cool or not cool? It's totally not cool. I was hoping somebody would call me out on that. Okay, so here's our algorithm. And here's what we've done. We've said, okay, give me an input file name, give me an output file name, open it, and if it doesn't work, then exit. But actually this time it did not create the output file. Sorry, it exited before that. But it's annoying to actually have to enter the output file even though the input file is going to fail, don't you think? So maybe we should change our check. Maybe we should do, instead of checking here after we ask for the output file name, we should check before the output. Do you think that's a good idea? How many of you all followed that? Because I'm going fast. Okay, so here's what all we have to do that is take these two lines and put them down here. And now we're good. So now, let me compile it again, clear the screen, I'll run it again. And if I give it a bad file name, it will fail quickly. It will fail quickly before it asks for the output. It's always nice to fail quickly. Yes, sir? No. If we create an empty file, I'm going to create this file data2.txt, which has stuff in it. I'm just going to take everything out. Okay. So now data2.txt is empty. With me on that? So now if we run our program and we give it an empty text file, it will still ask us for an output file. It's just, because it's empty, that's fine. Because it was able to open an empty file, the opening file. Everybody with me on that? Yes? Of course. Okay. So what I haven't done here is we asked for the input file right away, and then we checked. Now we asked for the output file, but we didn't check for the output file either, did we? So what I'm going to do is I'm going to kind of copy and paste some code here, and I'm going to check for the output file as well. Now, what I've done is this notation, not output file, works, but you can be more explicit and use a method called .isOpen. Like that. And this, if you try to open it, and it is, whoops, I screwed up. I need to move the open line too. So this, if you read the file, if you read the file name and you open it, and for whatever reason it doesn't open, this dot is open is essentially the same thing. Yep.
So what's the full the if statement for the output file?
This says if not output file is open.
Okay.
And input is open is a dot with something with parentheses, which means it's a method, and it's something that's built into this output file variable. And it will tell you after the open call if it's open or not. Because there's a chance that when you do this dot open method that it won't work. You seem skeptical. I'm going to prove it to you, okay? Like, why would a file never ever be open? So, yes? You can. I'm just showing you a different way of writing it. Yep. Yep. I just different. What I'm trying to do as I teach this class is like not just teach you one thing that'll work, but show you some other stuff that's commonly used, so that if you are reading other code and you encounter it for some reason, then you'll kind of know what's going on with it. Sir. Yeah. Why not? All right. Everybody good? Who's happy? Who's kind of unhappy? Who's hungry? I'm hungry. Yeah. Can't really help you with that. So. Yes, sir. You can take care of that. It's just a little more complicated. And I'm not going to teach you to do that right now. If you're really interested in doing that, send me an email and I'll tell you how. So his question was, what if you want to check and make sure the output file doesn't exist so you don't overwrite it? There's a setting for that. And that's actually called clobbering a file in computer parlance. If you overwrite a existing file, it's called clobbering. We're just always going to clobber files in this class. All right, so should we run this and see what it does? All right, so let's see if we can compile it still, if we haven't screwed up too badly. Compiled, I'll clear the screen, I'll run it. What data file name do you want to use? Do you want one that works or not? One that doesn't work? All right, so we know it doesn't work. Do you want to use one that works now? And do you want an output file that works or doesn't work? Doesn't work. All right, you don't really know this, but this is the name of the central password file that keeps track of all the users on the system. If we are capable of overwriting this, we are capable of giving ourselves super user administration powers over the computer. This is generally a file that's very well protected, so I expect if we try to write to it, we will be rejected. What? Oh, wait, I'm on a Mac, aren't I? What's wrong with that? Yeah, there's the user database. Okay. Sorry, I confused myself. I was like, what? How can you not find that file? Of course every system has that. All right, that was my dumb error message that I should like vomit up a candy for that, right? So for being that wrong. So this was our program telling us that that we weren't able to get access to that file, even though it totally confused me. Sorry about that. Boy, that's embarrassing. I'm going to edit that out. So. Okay. How about this? Instead of not found, we're going to make it not opened. Whew. And all right, so what's going to happen now? I'm just going to reshoot this part, data.text. Enter the output file name /etc password. It would help if I recompiled it, wouldn't it? All right, take 3. You know, it's pretty funny is next Monday I'm on a panel, because like this is all part of a big teaching grant that's university-wide, like the fact that I'm recording. And I'm on a panel to share my experience. And one of my very profound things I was going to say is that in the classroom, you only get 1 take. And now I'm making take 3. So, all right, so here we are. Let's give it a file name that we know exists, and let's give it one that we know won't work. And it said, not opened, which is what we expected. All right, let's move on from take 3. All right, everybody with me so far? So we've talked about how to open a file. We've talked about how to do a name, give it a name from a user, and we've talked about how to check if it worked. Yes, sir? Sure. Let's give it a non-existent file. So let's ls. I'll show you the files that are in here. Does anybody see a file named dog.txt? Oh, wait. For output, though, output, it'll be perfectly happy to output to a file that doesn't exist. So we see that dog doesn't exist, so we say data.txt. And if we say dog.txt is the output, it's fine with that. And now there's a file named dog.txt because that file didn't exist. And we have all the permissions to write to this directory. We have enough disk space. That's not a problem. The only way we're really going to run into a problem is when the disk is full, or if we're trying to write a file someplace that we're not allowed to. So yeah, do you want to follow up? How would you check? You can do that. You know how you do that? It's simple. Magic. Okay? It's just magic I'm not going to explain in here. Yes, sir. Uh-huh. Doesn't matter. Doesn't matter. It'll create whatever file we want. So if we run this and we say input data.txt and we say output Excel workbook.xls. Wait, they're XXLS. What are they now? SLSX? There we go. Now if we say ls, look, we created this Excel workbook. But yeah, but it's not really an Excel workbook. It's just some text. We can name the file whatever we want. No, there is no default. There is no default. It's going to literally write whatever we put in there. If you don't put anything, now you have a file named dog. Right? It doesn't. It's a text file. So here, I'm going to show you a magic command. There's a magic command in Unix called file, and then you give it the file name, and it'll tell you what it is. It tells us that's ASCII text. And if we say file io.cc, it'll tell us it's C source code, which is sort of close. If we say file Excel workbook, it'll say it's ASCII text. So. No, this is a program that exists on Unix, so it exists on CS class. If you want to figure out what a file is, you tell it file and the file name, and it's a program that will look at the file and try and guess what it is. So. Sure. Yeah. Okay. This is a difference between the Linux and Unix operating system and like Windows, right? Windows is anal about what the text extensions mean, and Linux and Unix don't care. Literally, they literally. It's helpful for you to understand that it's a text file. That's why I'm doing that. Mm-hmm. Yep, it is. Yeah, and that's just an operating system difference, right? It's the way Linux and Unix work versus Windows. So if you grew up on Windows where the dot at the end was like super duper important, then it's weird, but it doesn't matter. I just kind of use it as a convention because then it's less confusing. So, yeah. Yeah. Okay, so the question was, what does the .open actually do? Well, if we look at this, we have ifstream, which stands for input file, and ofstream, which is, so this is a variable that's essentially going to link the program to a file to read. But these variables, input file and output file, have to know which file they want, right? So the .open is essentially the thing that we use to link this variable to a particular file. So .open is a method that takes a file name, and what it says is go out and look for this file of this name, and if you find it successfully, then we're going to use it later to read data from. And isOpen is a different method that checks to make sure that open worked, right? Because we've seen the .open method may not work sometimes. It may not work because the file doesn't have permissions, there's not space, you're not allowed to read it, whatever. And so what it'll say is this doesn't give you a warning if it doesn't work, so you actually have to check and make sure that the open worked. That's what the difference is. Yep. Say again? Dot fail? I'm not familiar with dot fail. I'd have to look at the F-stream documentation and see. Is it in the book? That probably works then. So, and you know, I'm going to be honest with you. C++ is a huge language, and like the dialect I use doesn't use words that other people use. It's like the difference between how many of y'all are thirsty and you want something sweet and sugary and caffeinated, go get a Coke. How many of you get a pop? How many of you get a soda? A lot of you just don't drink that stuff. It's good for you. So, no, right? But so it's kind of like there's regional dialects and there's different ways to say the same thing. Yep. Because I was just showing you different ways to do it. They're equivalent. Yeah. You want to? We can. They're both pretty much the same. Yeah.
So what if your output file name is already the name of a file in the directory?
So what if your output file name is already the name of a file in the directory? It will overwrite the existing file.
Is there any way to prevent that?
Yes. Yes, magic. There are ways to do that. I'm not going to go into it in this right now because it's not important. No, it's not important for us. But it is in practical sense it is important. And essentially there's a thing that you can set called clobber or no clobber. And if you say no clobber, then when you try to write to an existing file, open will fail. So, but I'm not going to worry about teaching that. But there is a way to do it. Most of the time there's a way to do anything you want, particularly if it's something that makes sense, because if it's something that makes sense, other people have had to do it and they wrote it into the library. It's just I'm not teaching you everything, because we could have like a week on IF stream and OF stream, right, if we did every single thing. So I'm just trying to teach you stuff to get you going. Okay. Everybody good with this? Sir? It dies. So just like CN, it dies. And that's a good question. I'll give you an example of that. So here's our data.txt file. It has a number first, and we're going to replace the number with an interesting character. How about a bracket? Okay. What happens with CN when you get a data type error? It quits. What do you think is going to happen with IF stream? It's going to quit. So here's our data.txt file. I'll save that. We'll go down here. We'll rerun our program again. Now remember, data.txt has an input error, like a type error is the very first character. It output nothing. The reason it output nothing is because it got a type error right away, and it failed right away, and nothing happened. And if we move that error around, like if we put it on the second line, we would see the first line work, but then it would fail after that. Yes? Say again? Yes. I'm not going to tell you. Magic. Well, you'll know if it's empty. So here's one way to do it, okay? I think there's a way you can do it through IFStream, but here's the other way you can do it. So let's say we wanted to know if our file was empty or not. Okay. How do you know if a file is empty? You could read the file length. Yes? Uh-huh. Let me ask you this question a different way. How many lines does an empty file have? 0. So, what would happen if we counted all the lines in the file? Then a file that was empty would have how many lines? So let's count the lines in the file. How's that sound? Because I think you might need to do this too. So let's say int line count. Let's set it equal to 0. So now this int line count is going to be a variable that we use to count the number of lines that we've read as we go through the file. Everybody good with that? So the question is, when do we increment this count? When do we make this count 1 bigger? Every time we successfully read a line. And where do we know that we successfully read a line? Right here. And remember I talked about people using plus plus? This is commonly how you do it, right? Now remember, plus plus uses this variable first and increments it, but we're not actually using this variable for anything. We're not outputting it. We're not feeding it into a function or a method. So we just say line count plus plus. And what this says is if we have successfully read a line and we go into the for loop, make our count of lines 1 bigger. Does that make sense? Yeah. Mm-hmm. You're going to have to. That's exactly it, right? Because that's how you know how many subjects are read, because you're going to count them. Yeah, I mean, that plus plus is just one particular notation that we can use to make that variable larger by 1. It's commonly used because people who program are lazy, and it's the shortest way to do that. You get to save like 4 characters of typing by doing that. You're all laughing right now, but you wait and see. Yeah. Uh-huh. Yeah, you could create a variable instead of line count. You could create it called subject count, subject number, something like that. The mechanism is going to be exactly the same. How you choose to name the variable may be different. Does that answer your question? Sure. Sure. Yeah. Yes. Okay. All right. So let me just show you first. Let me just show you first that this sort of works. Okay. And what we're going to do is after the while loop, we're going to output how many lines we saw. So here's what I've done. I created a variable named line count. I initialized it to 0. Yes, it's a trick hand. All right. And what I'm saying is every time we successfully read a line, which means we look at the file and are able to extract 4 values of that type, and we get into the while loop, we're going to make a line count bigger by 1. Okay? So every time we read a line successfully, line count is going to grow by 1. At the end of the program, after this while loop finishes, because it's no longer able to read anything, we are outputting how many lines we saw by outputting line count. Everybody good on this? How many of y'all are happy with this? How many of you are not particularly happy at all? Okay. How many of you are still hungry? Yeah. More. Huh. Yeah, it's lunchtime. Okay. All right, so let me recompile the program, and we'll just look at this and see if it worked. So that was good, and we'll run it again. And sadly, that file had 0 lines. Why did it have 0 lines? Because we had a type error in it, yep. So, but if we get rid of the type error and we put it back, how many lines do you expect it to have now? Let's run it again and try again. This file had 3 lines. Yeah? Mm-hmm. Yep. Do you want to put the type error someplace else and show that? You don't seem very interested, but we'll do it anyway. So here, I'm going to put a type error down here on the 3rd line. Okay? And we'll run it again. The type error is now on the 3rd line. And it will only see 2 lines because it quits. It is not a foolproof way. No. It's only foolproof as long as you are guaranteed there are no type errors. And did I guarantee you there would be no type errors? I did. Yeah. So. Yes, sir. Okay, you all are really interested in this whole header thing, aren't you? The question keeps coming up. You want me to take care of the header for you? All right. Here's what we're going to do. So here's our data file. And I'm going to go ahead and put a header line. And the header line I put in here just tells what type of things there are. Does that make sense? Everybody with me so far, what we're doing? Do you remember why we're doing this? Why? We're doing this because the file that I gave you for the assignment has a header line, and you have to know how to get rid of it. Okay? Everybody good for this piece of magic? Great. Stand up, stretch, shake. 1 minute. You're all getting really restless, I can tell. I've been talking too long, haven't I? It's always good to end on a cliffhanger, too. So. All right. Everybody feel a little better? Sorry, I should have done that a long time ago. I could tell you're getting restless, but I wanted to get through stuff. So, okay, so here we are. We have this situation where we have a file that has a header line. Okay? Data.txt now has a header line. What is going to happen when we run this now? Why is it going to quit? What's going to quit? And it's not going to find it because it's looking for an int and it's going to find like a character, right? So it said it had 0 lines. And it said it had 0 lines because we had a type error right away. So we need some way to get rid of this header line, right? Don't we? So here's what we're going to do. Remember, the way that CN works and the way that input file works is that they take things by chunks, right? So if we gave CN like way more stuff than it needed, it would use what it needed and then it would save the rest for later, right? Do you remember that? So here's what we need to do. We need to use, and so what we need to do is have a way that we can just read that first line and get it out of the way before we get CN processing the other stuff. Everybody with me on that? Any ideas how to do that? Get line, okay. So here's what we're going to do. We're going to create a string called header line. And before we do anything with the while loop, we're going to do get line. Uh-oh. Yes? Why did I what? Oh, it just turned color because there was, it turned color because it's trying to show that I didn't have a semicolon. It's the way my editor works. It highlights things. And it's actually useful because it lets me miss like missing semicolons and stuff before the compiler does. So that's why it's turning colors. You can have this magic too. It's just more of a learning process. Okay. So getting back to this, we want to say get line. Where are we getting this line that we're trying to get rid of from? The keyboard? Where? The file stream, right? Because we're reading this file, and I'll flip back to the file for a second, and this file now has that annoying header line we have to get out of the way, right? So the way we're going to get the annoying header line out of the way is we're just going to go ahead and read it from input file. And where are we going to put it? Yep. Now what are we going to do with that header line? Nothing. Just going to throw it away. In fact, often when I do this, instead of writing the variable named header line, I call it trash or junk or more impolite terms, right? Just because I'm going to throw it away. But just so you understand what we're reading here, we're reading the header line. All right. Last time we ran this program, it said it had 0 lines. And it said it had 0 lines because it got the header line, it was looking for an int. It immediately, the input mechanism immediately quit on us and we were done. So let me recompile the file. Oops. And we'll rerun it. All right. data.text, output.text, bingo. Now, you're going to complain that it said it had 3 lines when it had 4. Is that what you're going to say? All right, well, go ahead. That's why I don't work as a psychic. Yes? Getline will remove everything up to the first return, right? So if we look at the input file, getline gets everything up to the first thing, so it just gets all of that out of the way. All right. In the past, I've given projects that had like 6 header lines. If you had to get rid of 6 header lines, how would you do it? Just do that 6 times in a row. Yeah, literally, it's that easy, right? The other thing I've done in the past for assignments, which I'm not doing to you now, is I've given you files that have like 1 line formatted one way and 1 line formatted a different way, and you had to like interleave them and stuff. It's actually really easy once you see how. It's just conceptually weird. So I'm just telling you this because I'm being nice to you. That's all, and I want credit for it. So, all right, just 1 header line makes it easy. Yeah.
So how does getline know
Mm-hmm.
to get the first input in?
Because what happens, remember what happens like with Cin or any input, it just starts at the beginning. And because that's the first thing we've done to do any input at all, right? Because getline is ahead of all this input, it just starts at the beginning. And it says, oh, I am starting at the beginning of this file, because that's what happens when you open it. And now the getline says, before we do anything else, get the first line. And it gets that line. And then the next line after that does input, right? Here's the get line. The next line, you know what I'm going to do? I'm going to do some magic. I'm going to show both at the same time, okay? It's a little bit easier this way. All right. So here's what's happening, right? We open the file and everything goes fine. And we reach this point right here above the get line. The file is open, and we're right at the beginning of the file because we haven't done anything. And the first line, remember, computer is just a mindless number crunching grinder. It is dumb. It's dumb as a box of rocks. And it just says, get line. And it goes, oh, I'm supposed to get a line. Here's the thing I'm reading from. It goes, do, 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 do. Where does the line end? At the end of the float. So it gets that line. And once it's done that, it goes, okay, I'm not very smart. I'm just going to keep going on. What's the next thing I do? I do while. Oh, while what? While I'm reading from the input file into these 4 variables. And it goes, okay, well, now I'm right here, because I already read the first line, 1 variable, 2 variable, 3 variable, 4 variable. They're all the right type. We're good. No, I did save it. There's actually a box in memory now called header line, because we needed to put it somewhere just to get it out of the way, but we're never going to touch that box again. We're done with it. One last question, and then I have a brief announcement for you. Yes? Uh-huh. Yeah. Mm-hmm. Remember, the computer is just a mindless number crunching machine that does exactly what it's told. Exactly precisely what it's told.